Okay, here's a question. It's a circle question, and you can see we've got a circle with a triangle inside. They've drawn a centre and called it O. CT is a tangent to this circle, which touches this point here. Okay, so just zoom out there if you want to have a go at that question. Again, you can see it's question number 17, which is a few from the end. So it's quite a challenging question and a little bit of circle theorems. Okay, so how we would look at this one. The first thing you'll notice, they're giving you that centre bit as a bit of a little bit of a clue, really. So if you just draw some lines like this to each corner, you'll find that might give you a little clue. These are all going to be the radius, because it's a centre to the edge of the circle. Now, because they're all radius, they're all going to be the same length. And as they're all the same length, I've just drawn that, it just shows that. Because as these are all the same length, it means that this one, and this one are also going to be not the same as those, but they're going to be the same as each other. So two little dots, two little lines to show that. Okay, so they're going to be the same. And then, which means if you have a triangle, 3 sides the same, that means it would be an equilateral triangle. So therefore, they have to be 60 degrees each inside that. Okay, now that will help us answer this question, because what we're trying to do is prove that BAC, which is 60, so this one here, is the same, so BAC is the same as BCT, so BCT. So we know this one's 60, we just worked that one out. And then BCT is this here. And the only thing you need to know on top of the equilateral triangle is that, I'll just use a different colour, is this, the radius and a tangent is always at 90 degrees. 90 degrees, sorry. Doesn't really look loads like a 90 degrees. Okay. So, and how we would write all this, I've got all the information I need now on there. And now we need to start writing how we prove this. So, first of all, triangle BAC is an equilateral triangle. And therefore has three angles of 60 degrees. Okay, and then therefore BAC, which is the one we were talking about, equals 60 degrees. Okay, so it's kind of shown that one there. Now what we need to think is, how do we know that this is also 60? Well, if we say that OCT equals 90 degrees, and that is because of tangent and radius angle. So we know that that is 90 degrees. And as that's 90 degrees, and here, this little one here, this whole, each one of these angles is 60, but then this is going to split right down the middle of that. So therefore, this smaller angle here has to be 30. So that's OCB. OCB equals 30, and that is because of that's half the 60 degrees from triangle. And then therefore BCT, which is all we need, equals 60 degrees as 90 minus 30. You can kind of see that there. And there's loads of ways you can kind of explain that. I've kind of, as long as it's kind of stepped out, structured, and you can see where you're getting that 60 from. Usually that's 4 marks. It does tell you the angle equals that. It doesn't ask you to find the angle. It actually says that it does equal that, and you just need to prove it. So I've done that. So BAC equals 60. You can finish it off if you want to. Therefore, BAC equals BCT. And that's it.